Continuing with the simplification of radical expressions, I'm going to work on this one that says x over 4 all divided by 1/3 plus x halves. So in order to simplify this expression, I need to find the common denominator for this fractions down here. So I'm going to write x over 4 divided by, my common denominator would have to be 6, right? So I can take it here. 6 divided by 3 is 2 times 1. So it's 2 plus 6 divided by 2 is 3 times x, 3x. Okay? But from here, I know that when I divide fractions, that's the same as multiplying. So I can say x over 4 times 6 over 2 plus 3x. After multiplying these terms, then I know that I have 6x divided by 4 times 2 plus 3x. Then I can take half on these to reduce the 6 and the 4. So I have 3x over 2 times 2 plus 3x. And that would be my final answer. That was a rather simple expression to handle. Now let's go to this one, which is a little bit more complex, because we have to remember the arithmetic order of operations. So I have a squared b minus ab squared over a squared plus 2ab plus b squared divided by ab squared over a plus b times 1 over a minus b. So we have to be careful with the order of operations, because you may be tempted to multiply these together before dividing, but that will give you a completely different answer to what you are actually supposed to do, which in this case is to divide this expression by this, and then the result multiplied by 1 minus a over b. So let's simplify this expression here. So that means that I can extract AB. So I have AB times A minus B divided by, this is squared, this here, this expression here is the same as A plus B times A plus B. If you notice, a squared, ab plus ab is 2ab, and plus b squared. Now, if I am dividing this expression by ab squared over a plus b, that's the same as multiplying by the inverse, right? So I can say a over b squared, and I'm going to put this in parentheses so I don't get confused, then times 1a minus b. Now, when I multiply these together, I notice that I have an a plus b term here, which cancels with one of these a plus b terms because it becomes 1. Then my a gets canceled here, and then the squared at the bottom, and that means that and the 1 on top, I only have one b on top, then I end up with b at the bottom. So this b cancels, and I have this one. So my ending result within the parenthesis is a minus b divided by b times a plus b. Now, this expression I must multiply by 1 over a minus b. But if I am going to multiply that, notice that my a minus b here and my a minus b at the top, then they cancel out. And so my final answer will be 1 over b times a plus b. And that is my final answer. I do have one more exercise that I want us to look at, and since it's part of this, I'll just switch pages. And this one, again, I wanted us to do it because it's a little bit more complex than everything that I've shown you. Now we have fractions on top with a fraction at the bottom. So the first thing that we must do is we need to find common denominators. In this case, the common denominator for the top and bottom, for the top expression is x minus 1 times x plus 2. So if I divide this, then it will be 3 times x plus 2 plus 3 times x minus 1. And I have to divide that by 3 over x plus 2. Continuing with the operations then, Continuing with the operations, I have here 3x plus 2, that would be 3x, plus 6, plus 3x minus 3 over x minus 1 times x plus 2 divided by 3 over x plus 2. That is the same as saying 3x plus 3x is 6x plus 6 minus 3 is minus 3 over x minus 1 times x plus 2 divided 3 x plus 2. Now, remember that if a fraction is dividing, then you can multiply it by the inverse. So we can say 6x minus 3 over x minus 1 times x plus 2 multiplied by the inverse of 3 over x plus 2 is x plus 2 over 3. Now noticing x plus 2 cancels out here. Now I can extract the 3 from this expression, so that would be 3 times 2x minus 1 over 3 times x minus 1. So these numbers cancel out, and I end up with 2x minus 1 over x minus 1. And that is my final answer. I hope you enjoyed this. If you have any questions, please do not hesitate to ask them. And I will see you soon.